Hello, my dear Java developers. Welcome back to our channel. Today, we are embarking on an exciting journey into the world of blockchain, specifically tailored for you, the Java enthusiast. Have you ever wondered how cryptocurrencies like Bitcoin work, or how data can be secured in a truly immutable way? Well, blockchain is the answer. And Java is a fantastic language to understand and implement its core principles. In this 5-minute tutorial, we will break down the fundamental concepts, from what a block is to how a chain is formed, and even a simplified version of mining. By the end of this video, you will have a solid foundational understanding and even some Java code to get you started. So, grab your favorite cup of chai and let us dive in. Alright, let us start with the building blocks of blockchain, literally, the blocks and hashes. Imagine a digital ledger where each page is a block of information. This block contains data, which could be transaction records, messages, or any digital information. Each block also has a unique digital fingerprint called a hash. This hash is generated using a cryptographic function, like the secure hash algorithm 256 or SHA-256. If even a single character in the block's data changes, its hash will completely change, making it incredibly sensitive to alterations. Our Java block class demonstrates this. It stores data, a timestamp, and a reference to the previous block's hash. The calculate hash method uses SHA-256 to create this unique identifier. This is the cornerstone of blockchain's security and integrity. Now that we understand individual blocks, let us see how they form a chain. The magic of blockchain lies in how these blocks are linked together. Each new block contains not only its own data and hash but also the hash of the previous block. This creates an unbroken, chronological chain. If someone tries to tamper with an old block, its hash will change. Consequently, the hash stored in the next block will no longer match, breaking the chain and immediately revealing the tampering. This property is what we call immutability. Once a block is added, it cannot be changed. Our blockchain class in Java manages this chain. The addBlock method takes a new block, links it to the latest block by setting its previous hash, and then adds it to our list of blocks. The isCainValid method demonstrates how we can verify the integrity of the entire chain by checking these hash links. Building on our understanding of blocks and chains, let us explore a practical example, a simplified version of mining. In many blockchains, new blocks are not just added, they are mined. Mining is the process of performing computational work to find a specific hash for a new block that meets a certain difficulty target. For example, a difficulty of 2 might mean the hash must start with 2 zeros. Miners repeatedly change a value called a nonce within the block until its hash satisfies this condition. This process is known as proof of work. Our mineBlock method in the block class takes a difficulty level. It then iteratively increments the nonce and recalculates the block's hash until the hash starts with the required number of leading zeros. This work-intensive process makes it difficult and expensive to tamper with the chain, as altering one block would require remining all subsequent blocks. As you embark on your blockchain development journey, it is important to be aware of common pitfalls and best practices. A common mistake is thinking that blockchain is just about Bitcoin or other cryptocurrencies. It is a technology with far broader applications. Another pitfall is neglecting scalability or security best practices in your implementation. Remember, the strength of a blockchain comes from its cryptographic security and distributed nature. Always ensure your hashing algorithms are robust and consider the implications of your data structure choices. For example, storing large amounts of data directly on the chain can be inefficient. Instead, store only relevant hashes on-chain and keep the actual data off-chain. Always thoroughly test your chain's validation logic to prevent vulnerabilities. Focus on understanding the core principles before jumping into complex frameworks. And just like that, we have covered the fundamentals of blockchain for Java developers in just a few minutes. We started by understanding that a blockchain is a series of blocks, each containing data and a unique hash generated by algorithms like Secure Hash Algorithm 256. We learned how these blocks are linked together by including the previous hash, creating an immutable and transparent ledger. Finally, we explored a simplified proof-of-work mechanism, or mining, where computational effort is used to add new blocks securely. Remember, practice is key. Try to expand on our simple block and blockchain classes. Add more complex data, implement transaction handling, or explore different consensus mechanisms. If you found this tutorial helpful, please give it a big thumbs up, share it with your fellow developers, and do not forget to subscribe to our channel for more exciting Java and tech tutorials. Keep coding, keep learning, and I will see you in the next video. Namaste.